Hey everybody, welcome back to another physics lab. Today we got lab 3. No, we got lab 2, and this one's a doozy. All right, yeah. So let's just go ahead and just dive dive right into it. No sense in stalling. Introduction. So today, the point of today is to model the magnetic field of a bar magnet, and that's no easy task. We're gonna use multiple different equations, multiple different of my eyes. I use both of them. Look, just do lots of analyzation. You get the distance dependence formula, John Lennon, and the magnetic field of a bar magnet. And here you can see this is the magnetic field of a bar magnet. We have the north side and the south side, the Bloods v. Crips, the red v. blue. All right, and so for the experiment, basically what we did, we got a magnetometer and put it next to we put it next to the other magnet. And so basically then we use our phone to measure the magnetic field of the sick magnet field. Okay, so here's the data that I collected. You can see that with the change in the distance, you've got an inversely proportional relationship between the natural log of r and the natural log of bx. So that is the radius of the magnet and the magnetic field. And we found a relationship of y equals negative 2.7364x minus 14.222. And yeah. And so with that, we found that our equation was y equals negative 2.7364x minus 14.222. And the mu, or the magnetic dipole moment, is 3.33. And here is my code. Wait, I just have to finish writing it up real quick. And as you can see, that gives a nice oh god, sorry. So as you can see, this gives us a very nice demonstration of the magnetic field of our magnet. And you can even see, you can look around a little bit. And yeah, so all those arrows, they're all pointing in the right direction. It's all looking good to me. So that's some pretty good code, if I do say so myself. Errors? Nah, not really, honestly. It all looks pretty good from my end. Okay, you got me. The magnetometer could have been slightly off, I suppose. But that's neither here nor there. And so, I knew what you might be wondering. What if, in this experiment, we oriented the setup so as to compensate for magnetic north? And so what if you hadn't done that and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? So this is a really interesting question, because you would actually end up getting a lot more different magnetic fields in directions that are less predictable to the answer, which, I mean, that's no good. That's not what we want. So it's honestly pretty good that we took into account which way is north. Okay, so now what you may be wondering is, imagine if you had two identical magnets and redid the experiment, but use a single magnet instead of instead of using a single magnet, we use two identical magnets stuck together end to end. So that would be really complicated, and it would probably actually double the magnetic field, because the magnetic fields of each magnet are actually interfering with each other, and it gives positive interference. Okay, So pretty much, guys, that's pretty much it for today. Yeah, you guys are the bomb. Thanks for watching. Skadoosh.